Hey guys, this is my introduction to videos video. I'll try to keep it fairly short, but I kind of just want to go over a few things before we get started with the actual review videos. One of the things I want to answer is why we do videos. Why do we care about doing these things? Well, the reason why we do videos is a few things. One, chemistry is a comprehensive topic at all times. We learn what we learn in chapter 1 we'll use in chapter 10. It doesn't matter. And if you miss out, say you don't get naming in chapter 2, well, you're gonna miss all of the problems that have anything to do with that in chapter 3, chapter 4, chapter 5, etc. If you don't get chapter 3, stoichiometry, you're gonna miss chapter 4, chapter 5, etc. Okay. So it's a comprehensive topic. So if you miss something, if you don't get it, I mean, of course we do quizzes in class, so you can't really miss all the time. But if you don't understand something, how do you get it? Well, besides me standing up there in the class and getting blue in the face, saying it over and over, we can do these review videos and kind of talk about the things that most people miss. So why do you care? Why do you care about these videos? Well, hopefully you use these videos as a tool to complete your understanding with things that you missed in class. Now you're going to have reading assignments and homework assignments and everything else, and hopefully you can rely on these to fill any gaps that you have. Now, if you look at Blackboard in the content section, we have all of these videos kind of broken up by chapter. There's 5 different videos, at least, maybe 6, depending on the chapter, for each chapter that we're going to go over for the semester. And they're broken up by topic, so you can really home in on what you're missing. So you don't have to watch an hour-long video on chapter 2, for example, if you're just missing acid naming or whatever. Now, what I want to talk about a little bit is when to use the videos. Do not use these as a comprehensive study tool. Okay, these are here to help you fill the gaps in your understanding. That's it. So don't, miss class all the time and rely on the videos when it comes to the test. They're here to help you figure out what you're doing wrong, where you're missing something. Now, since it's at the very beginning of class, what I want to do is talk about mastering chemistry and learning catalytics, 2 tools that we're going to use in the class. Now I'm going to open my mastering chemistry, or open my browser, and it's going to be on mastering chemistry. There it is. And when you sign in, it's going to ask you for the course. We have a course code, and it'll just pop you to my course. I opened just a random course, just that has my stuff in it, just to kind of show you around. Now this is what it's going to look like on the course home. If we scroll down, you'll see a calendar. If we continue scrolling, it may be on the top right, but you'll see an in-class learning thing. It's learning catalytics. Now I'm going to start looking at the assignments. Now if you go over to assignments, you won't see all of them. What you'll see is the ones available and the ones past due. Now our reading quizzes this semester are going to be online. They're pretty short, kind of just tutorial-based things that have an adaptive follow-up assignment to them. Now, the follow-up assignment is based on how well you did on the reading quiz. If you missed everything, you may need 30 minutes of follow-up. If you missed a couple things, you may need 2. If you got 90% of it, you don't need any. The homework assignments will be much the same. So it benefits you to give it a shot, see where you're missing it, and then go through and do the follow-ups to help you kind of bridge any gaps. Now, the nice things about the reading quizzes, the homework assignments, this is just the introduction, but the homework assignments and the in-class quizzes is that they're all linked to learning objectives, and they're all linked to topics. And so what you can do is we can look at what you're missing, where you're missing it, and then go to the videos and show you kind of where you're getting it wrong. Let's go back to the course home and go down to the bottom. Now, Learning Catalytics is our in-class kind of interactive program. All of you are going to have a smart device, whether you need it or not, whether you need it provided or not. You are going to have a smart device. Now, when you click on the Learning Catalytics, you'll come up with something much like this, where you can put in a code for a specific class. So for me, if I open a class, it's going to look a lot like this. If you look at the top here, there's a code. That code is specific for that class period. Now, when you go into Learning Catalytics, there'll be a place to put in this code. And when you put in the code, it'll take you directly to our class period. Now, we're going to use this to communicate during the class, answer questions, do examples, all sorts of other things. I can show you videos. It's really cool. One of the nicest things about it is that you have available to you a tool to anonymously ask me questions during class. So I know a lot of you may be kind of shy about asking questions, about raising your hand or whatever. You don't want to feel stupid. Everyone gets it but me type thing. But you can ask me questions anonymously using this program. Now, the other nice thing about it is that we've got a lot of options. You can see in this one, we are actually going to be drawing a titration curve. So we have drawing examples here. We can also have picture references. We can also have little videos. We can do all sorts of stuff using this program. It's really awesome. And the nice thing is that you don't need any Flash or Java or whatever. It runs fine on everything. Okay. So that's Mastering Chemistry and Learning Catalytics. You are going to have both. If you bought a used book, you are going to have to buy both. And that is just unfortunate. But at least with the used book and a little bit in the online stuff, it's not that expensive. I think it's $40-something, I want to say, for Mastering Chemistry, and Learning Catalytics is only $12. And Mastering Chemistry comes with our book currently, so that's nice. Now, going back to our little slideshow, let's talk a little bit about what's expected in the class from me and from you. For me, my goal in chemistry is to get you, this is going to sound really cliche, but to get you to think. A lot of people have problems with chemistry, not because the content is difficult, although everyone will say otherwise, but I promise you it's not. The only reason why people have difficulty with chemistry is they have, especially general chemistry, is that it's a different way to think. It requires you to use tools that you can learn from class and apply them to new ideas. And not just that, but it also requires you to remember things from one day to the next. And so, like I said, it's a comprehensive subject. You have to know naming to get stoichiometry, to get gas laws, to get all this other stuff. You have to continually build on what you learn, and you can never forget what you learned at the beginning. So that's important. And so you can expect me to try to get you to think like that, to be able to approach problems critically and approach problems comprehensively. What I expect from you is to try. That doesn't sound like much, but you have to realize what this class is asking of you. You have homework assignments, reading assignments, pre-labs, a group assignment, all these things outside of class. And in class, we're going to be going over practice problems, the information. It's a very fast-paced and very high expectation course. You have a lot of things that are required of you, and it's going to take a ton of your time. Just be prepared for that. And if you need help with time management or how to study and things like that, we're gonna talk about that. But that's what I expect from you, is to try on everything, is to try your best, and I guarantee it, I can get you to where you need to be. Speaking of chemistry, what is chemistry? Just as an idea, the general definition of chemistry is the study of matter and the changes it undergoes. Matter being anything that has mass and takes up space. And when we say changes, we mean doing anything, okay? Moving, reacting, changing physically. So really, chemistry can be boiled down to the study of anything that has mass doing anything, okay? This encompasses broad terms in biology, and then we have small terms in quantum chemistry and things like that. So chemistry is such a broad subject. I think the only subject that's broader may be physics, but maybe even not so much that. So you can see that we have a ton of things to talk about. Everything from every facet of things doing anything. Gases reacting, solids doing their thing, solids existing, liquids doing their thing, solubility rules. We just have so much to talk about in a single semester that sometimes it can be kind of overwhelming. But the nice thing is that they're all also related. We can talk about things and build on themselves, and so it never seems like that much at any given time. Just when you look back, it's pretty crazy. And what I want to end with is just a little bit of talk about science. You know, a lot of times people think that science is this big lofty thing. You know, only crazy madmen in lab coats can do science well, and you are as a freshman or taking this class can be expected to think like a scientist. Now, I want you to do something for me. I want you to think about any problem you had recently, whether it be your pipes breaking or your car breaking down or whatever the case may be. Okay, I don't know, really any problem that you can think of. And I want to analyze that. I'm going to use the lights going out as an example. Okay. And I want you to think about the process that you think of whenever you have this problem. So in my case, my lights go out. Okay, the light bulb in my living room goes out. That's my observation. It's dark. The light's not on. Okay. Well, I'm going to make a hypothesis from that observation. Well, the light bulb burned out. I'm going to form an experiment. That is, I'm going to change the light bulb. If I change the light bulb and my light doesn't turn on, well, my conclusion is that my hypothesis was false, and I'm going to have to change my experiment. So maybe maybe the fuse burned out. I'm going to go to the fuse box, or maybe I need to call the electric company and see if the electricity's out. The point here is that science is human nature. And that's such a cool thing. That's such an awesome thing to understand. That science isn't this lofty thinking that, crazy guys in glasses and lab coats do. It's an extension of human nature. You think like a scientist every single day of your life. The only difference is where your observation is the car breaking down, the light bulb going off, whatever. A scientist's observation is something about nature. Why does the earth behave like it does? Why do atoms combine in this ratio? But the thought process is the same. It's so cool because anyone can do it. It's human. It's taking what we do as humans and applying it to our surrounding world. That's all science is. Anyway, I'll see you guys in class. Don't forget to do your syllabus quiz. I know that's due soon or not, depending on when you watch the video. But just don't forget that. And I'll see you guys in class.